So today we're going to be looking at how to find domain and range of functions. And I've prepared some questions that will help us. Maybe I send that to you guys first. Okay, how about I send that to you guys first? Which chat will be better, right? Okay, from 5. Has it been that long that I had messages from you guys? Yes, that was on Monday. Anyways, coming up, question bank. Yeah, check your WeChat, everybody. Confirm when you get the documents, please. All right, good. All right, so we're going to be practicing how to find the domain and range of function. That's all I want us to have a look at today. Let's write the board. So we're still on functions, and today is all about domain and today is 27, 2 days to the end of February. So the topic will be domain and range of okay. So our main objective is to either by algebraic method or by graphical method to be able to identify or state the domain and range of functions, all right? Should be able to state domain and range algebraic or graphical. So I'll put it that way. So there will be a discussion on this. So please, I need your mic to be working. Okay. All right. So if I go by that worksheet, I have some graphs. Okay. Let's start with question 1. Do we start with question 1? Question 1 is to identify. Okay. Before then, let's do this. Can somebody remind me what I said about domain last time? Domain of a function. Does anybody remember? Come on, guys. I don't want absolute silence.
Do you mean how to find the function or what?
What does domain of function mean?
Oh, domain is like the x values, like the argument, and then function is the outcome from
The function or
I mean
range?
the range is the outcome from putting the x values into the function.
That's it. Domain df, if the function is f, is set of possible, let's say, if y is a function of x, okay, that set of all possible values x that f of x can take. Okay, does that make sense, everyone? Domain is all possible values that it can take. If, for example, my function is 1 over x, although we would not be talking about rational functions yet, we'll just talk about the ones that are not, like polynomials, basically. If you have this, you cannot put minus 1. Do you agree? So in this case, our domain will exclude minus 1. So if I want to write this, I will say domain is all x such that x is not minus 1, but x is, I can put here x belongs to R, but x is not minus 1. We'll talk about this. Range, like Lillian said, set of all possible values of y. Remember, y is f of x. So all these y values that are produced when we substitute or when we put in x. Remember, x is in the domain. Okay? If you put in all possible x, what are all the possible y's you can get? That's our range. So we look at it in two ways. We look at the algebraic method by just inspecting the function. Then we look at it graphically. If you can get the graph of the function, then you can get the domain and the. So on the xy plane, your domain is the region occupied, the x region that you can see on the graph. If you plot the graph, I'll show you an example. Let's look at this function. Okay, maybe not this one. Let's, can you see my screen? All right. So let's look at, just a sec. Y equals maybe x squared. Or maybe I say y equals 3x plus, something like this. My domain is all possible x. Now, if you look at this graph, this continues. Can you see this x values continues indefinitely towards the right, although it doesn't show much. Okay, this parabola goes like this. Does that make sense? So every value of x here at one point or the other can be substituted. And it makes sense because you can put in 10,000, you can get a y value. You put 20,000, you can get a y value, not just what you're looking at here. This continues. It's just that the y values are so huge that the x value looks so small. Okay? By the time you put 10, look at it. By the time you put x is equal to 10, this is probably 302. So you actually need to get to 302 for it to cross that line 10. So it crosses. Okay? If you put in x is equal to 30, that you have to get to 903, that's 2702 for it to cross 30. So basically it crosses all those values as well. It's just that it takes a very large value of y to cross it. Am I making sense? So my point is all values of x can be substituted, whether positive or negative x. So for this function, I could say my domain is, so maybe we write that on the board. So let's say find range of so my domain is every x, positive or negative. Do we agree? Talk to me, please. Every value of x. So every value of x can be substituted. So to write that, I would say domain is equal to set of x in R. That is all real numbers. That's all. There's no additional condition. Okay, that's my domain. My range. If I put every x, the first thing you think about is, even for domain, is what are the possible values you cannot get? For example, in the domain, I could say, what are the possible values that can be substituted here? We realize that there is no value that cannot be substituted. So as a result, domain is all real numbers. Does that make sense? So similarly, you look at the range. What are the possible values that you can never get? Anyone? What are the possible values you can never get? Because the range is the possible values you can get. Okay, Brandon said anything less than 2. Yes, you can't get anything less than 2 because the least in this 3x squared, for example, the least number you can get here is a 0. If you put in 0, this term becomes 0. If you put in 1, this term becomes 1. If you put in -1, this term becomes, 3, right? This is 1, then everything becomes 3. Am I making sense? I start that again. Let's take it one after the other. Secondly, you are right. So 3x squared plus 2. Let's consider it one by one. Let's consider x squared, then 3x squared. This can either be 0, 1, 4, right? So when you put in 0, you get 0. You put in 1, you put in -1, you get that. So I'm considering only whole numbers because it's easy to work with in my head. Same happens to 0.5 or whatever. So the point is the values of x squared can either be 0 or more. It can't be negative. When you multiply that by 3, you still get 0 or more. Now when you add 2, you get 2 or more. So the minimum you can have that this function can produce is 2. Okay? The minimum it can produce is 2. It can never be less than 2. So when you're writing your range, you say range is set of y in R, okay, that is real numbers y, such that you can write it such that with a vertical line, okay. If you don't want to use a vertical line, you can use 2 dots. So I'm going to use a vertical line such that this is called set builder notation, okay. I think we mentioned that before. Such that y is at least 2. Any question? Y is at least 2. Graphically, if you come to the graph, we can see this clearly. Look at the graph. The domain is all possible x. We've talked about that. The range is all possible y. What's going on? Oh, yeah. X1, Y1. Okay. 3x squared plus 2. Sorry. I'm trying to show something here. Okay, here is it. Look at it. The y value started from just 2, right? The y value, there's no y value below 2. Can you see that? Can you see my cursor? So there's no y value below 2, okay? So the range are the possible values from y. So it's like drawing a straight line along y-axis and see where the straight line can move, can intersect with the curve. So the straight line can only intersect with the curve starting from 2 and above, okay? So the possible values you can get is from 2 and above. That is why on the board we have written that the range is all real numbers from 2 and above. So this is how you read this. Set of y, set of real number y, such that y is at least 2, okay? So this, when you open this bracket, that's like set of y belongs to R, set of real numbers. Remember the script R, this vertical line is read as such that y greater than or equal to 2. Am I making sense? So algebraic wise, you can always find your domain. Graphical wise, you can always find your domain. Let's see, what if we have like a positive square root function, okay? Positive square root. So y equals square root of x minus 9. Okay. Oh, I should have said domain of y because I called it. Okay, since I'm going to write that as a df, I'm going to change this to I'm going to change this to f of x. Okay, because my notation must be consistent. Okay, so this function is called y, so my domain of y. I think we better stick to, because I'm going to use y here for my range, so I'm going to stick to that f of x to avoid any. So I'm going to stick to this f of x. Okay. All right. So domain of this function, then range of this function. Let's try together. What would be the domain of this function like? And please turn on your mic and talk to the class, not just typing. I'm waiting, guys. Don't waste time, please.
Is it set a real number x such that x is greater or equal to 0?
I'm not so sure. Think again. Close.
Should it be x greater than 9?
Greater or equal to 9.
Oh, okay.
Because x could be 9.
Oh yeah, I meant 9.
Yeah.
Like,
Yeah. X could be 9. Thanks to both of you. Others are too quiet and I don't like it. So the domain is set of real number X such that X is greater than or equal to 9. Okay. What about the range? What are the possible values that can be produced when you substitute from 9 and above? Yes. Waiting.
Is it set of real numbers y such that y will larger and equal to 0?
Y like that. So y cannot be less than 0? Huh? Krista, I'm going to ignore your comment. I ask you to speak to the mic. Thank you. Yes, Nakita, you're right. Y is greater than or equal to 0. Can someone tell me why we cannot consider all real numbers y? Why do we have to restrict it to greater than or equal to 0? Why not the negative side? Come on, guys, you need to encourage me here. Your silence is discouraging, and I don't want to get bored in this class.
Because x has to be greater or equals to 9, and when x equals to 9, it's square root of 0, and the answer is 0.
And even if x is more than 9, you cannot get a lower number than 0. That's very correct. So that's very, I hope everybody understands what she has said.
But I'm kind of confused because when you square root a number, can't you get like a positive and also a negative?
I think I mentioned something at the beginning, the function positive square roots, not plus or minus. I mentioned that at the beginning. I didn't just indicate it. So we're only discussing the positive square root.
Oh, okay.
Okay, because we already said it last time that positive, the ordinary square root would be like y squared equals x, and this is not a function. We discussed that last time, right? Are you confused? We discussed
No,
last
I think I get it.
y equals x is not a function. The graph looks like this. It fails the vertical line test.
Okay.
Do you remember the line test?
Yeah.
So this function fails the vertical line test. So that's not a function. And remember, y squared equals x will be y equals plus or minus square root of x. So it's still the same. So that's why I said at the beginning that we are only talking about a positive square root. I mentioned even though I didn't write it down. So positive square root x minus 9. And this is a function. Let's look at it in the graph. Y equals square root of x. Let's plot that on the graph. Hopefully I can indicate that I'm only interested in the positive square root. Y equals square root of x, square root of x. Okay, now look at that. Do you see? Can everybody see this? I can't see your comments if you're typing. I'm trying because I have to minimize, maximize all the time when you type in. So please stop typing in and speak. Thank you. I have to minimize, maximize all the time. And I don't want to do that. All right, so if you look at this, your domain is the x-axis. And you can see that your x-axis begins from x equals, wait, that's not the function. The function is x minus 9. All right, can you see? So it begins with, can you see, it starts exactly on 9. Okay, so your domain is set of x, like we said, such that x is greater than or equal to 9. So on x-axis, so your domain is, where does it start from? It starts from 9 and it goes forward, right? On y-axis, it started from y equals 0 and above. Understood? Understood? I'm waiting for response. Do we understand? No one is saying anything.
Yes.
Anyway, so that's about this. So you can look at it from the graph, or you can just try to imagine what can you put in and what can you not put in. So let's go to the worksheet and let's try to answer question. Can we all see the worksheet? Let's see. Question 1 asks you to determine if it's a function or not. And for those that are functions, state the domain and range. Question 2 is about domain, range, and whether the graph is a function. Okay. Let's consider question 2. Okay. Let's consider question 2. Everybody attempt question 2, and I will call you one by one to explain. So there are 9 questions basically, because question 1 asks domain, range, and whether the graph is a function. So there are 9 problems. I'm going to be calling 9 people to tell me what they have found out. Then after that, you can move to question 3. Okay, you can move to question 3. Then we will move to maybe question 4. So please start question 2. Let's see if okay, I think from 2 we can move to 5. Yeah, we'll do 2, then we'll go to 5. The rest can always be considered later, 5 and 6. Okay, so we'll do domain, range, and whether it is a function. I think I will leave one question for each person. Okay, one question for each person. How about I assign you guys to questions now? Let's look at the lists in the class. Of course, everybody must do every question, but the question you will be explaining to me will be assigned to you now. So please pay attention. I'm considering the list of participants in the room, so it's in alphabetical order. Brandy, you will answer question 1. Okay, question 2A, this one. Karen, you take 2B. Clarissa, you take 2C. Then Callista, you take 5A. Krista, you take 5B, which is 5B in order. Ethan, you take 5C. Krista, you take 5D. Krista K now. You take 5D. Let's see. Leo, you take 6. Lillian, you take 6B. Leo is 6A. Lillian, 6B. Nakita, you take 6C. I think the last person is Vena. Okay. Let's pick one from you here. Pena, I want you to take 7F. It's quite complicated, I know. 7F. Does everybody get their question? All right, so focus on your question, especially, and let me know when you're ready. And everybody is expected to explain, speaking to the mic, tell us what you have found, the domain and range especially. Just focus on the domain and the range using the graph. The graph is already sketched for you. What do you mean your mic is broken? Every computer can, have this. You don't have to have a special mic. Have you tried to speak to your system and nothing is happening? Can you try that? You need to check your settings, how to fix the mic internally, because I don't think you're using an old computer. These are new computers you guys just got to Form 5, I believe. So I want to believe you just need to find a way to do the settings. Your mic shouldn't be broken. But in the absence of that, you can explain with a voice note and send to me on WeChat. I can't hear you. So you must be able to maybe do some settings. So you can check a microphone or whatever on your computer. Okay, can you see this microphone setup? Okay, so maybe you can check that on your computer. Okay, can check that, but anyway, that can be done later. Let's focus on the work at hand right now. If anyone is ready, signify in the chat room, or you just raise your hand, then I'll call you, then you can explain to the class what you got and how you got your arrive at your answers. Everybody has the document, so I'll be moving through this one. Signify when you're done, please. Done, I think. Okay, Mr. B, turn on your mic and explain to us what question did you do and what do you, I think you're the first one, right? Yeah, 2A. So explain to us, sir.
So the domain is X is every real number. Is it like?
That's right.
Okay, and then the range is every real number that is y is every real number that is larger than -4.
Good.
Wait, larger or equal to like negative. Wait, what? -4. Larger or maybe larger or equal to. I'm not sure.
Okay, I'll take that from you, but I think it's going to be larger than -4, not larger or
okay.
equal to, because
Then
that
larger.
is an asymptote. We'll be talking about that on the rational function. Okay, so when you see a dotted line like that, it's telling you that the line doesn't touch it. The line is just getting close to it. All right.
Oh, okay.
So it is larger than -4. That's very well done.
And also, it is a function.
It is a function, yes, because if you look at the vertical line test, it doesn't fail, right? It doesn't.
Yes.
Thank you. And this arrow is what does this arrow represent? Do you know?
Which arrow? Where?
This arrow, can you see my screen?
It represents, it just goes to like infinitely small or something.
That's why it is all real numbers. Because you might be given a graph. If this arrow is not included, it means X stops here. Does that make sense? If this arrow is not included, it means X also begins from this negative value. But this arrow means it continues indefinitely. That is why your all real number R is accepted. Okay? Well done, sir. All right, Karen, which one is your question?
2b.
2B. Okay, let's hear you.
I'm not sure, but
No one is sure about anything. Just speak with confidence.
okay. X, wait. X is a set of real numbers. And, oh wait, the domain. X is a set of real numbers. And for the range is a set. Sorry, what?
You mean all real numbers, right? There is no exception.
Yeah, all real numbers.
Perfect, that's correct. What about the range?
And for the range, Y is a set of real numbers where Y is either greater and equal to 1 or smaller and equal to -1.
Perfect. Either
And
greater than or equal to 1, that's above, or Y is so it doesn't include the values between -1 and 1, right?
yeah.
That's very good. You see, that's why you need to be confident in yourself. All right.
Okay.
Mr. Chang, you're next. What question? Start with
5C.
question. What?
5C.
5C. Let's see, 5C. Okay, go on, sir. This is 5C.
Yeah. So the domain is a set of real numbers X such that -3 is less than X, and no wait, X is greater than -3 and less than 2.
Okay, I will. Yeah, that's correct. So I want to see how that is written. So
Okay.
I will expect you to say, so 5C. So domain set of X in R. Okay, you have to state which sets, okay? So -3, instead of writing separately, use this notation.
Wait, no, not less than or equal to, just less than.
Just less than.
For the, no, X is greater than 3, -3.
Greater. I just told you what to do now. There's no greater. You didn't see what I just wrote now.
Yeah.
I didn't say greater. I said use this combined approach.
Yeah, I know that, but wait. No, like the signs themselves, one of them shouldn't have the line underneath. I sent to you on WeChat what I wrote.
Okay, so you tell me what I should write. You use the word greater, then I said the word greater shouldn't be. Nothing.
No, because I don't know how to say it. I know how to write it, but I don't know how to say it. So I sent you on WeChat what I wrote down.
Okay, let's see. -3. So what is it? What exactly is difficult in this? -3 less than X less than 2. That's all you have to say. That's what you have written. Okay? Now let's consider the Y. So for the Y, let's see. Aha. So it's the same, right? -5 less than Y, not less than X.
Oh, yeah, yeah.
That's correct. -5 less than Y and less than 2. Less than or equal to 2. Yes, that's correct. So the next person that said done is Callista. Callista, you have my attention. What number and what do you have?
5A.
5A?
5A.
Okay. So let's go to 5A. So everybody sees, so that's 5A. So what is your domain?
X is real numbers such as 2 is smaller or equals to X, but it's smaller than 6. Does that make sense?
So when you say 2 smaller or equal to X but less than 6, is 2.5 part of it?
Wait, no.
But that is the meaning of what you just said.
Smaller or equals to 5.
Okay, so you said X is what? So let's say domain is set of X in R. Then you say such that X is smaller than what?
Smaller than equals to 5.
X is smaller than or equal to
But
5.
bigger and equals to 2.
So I write bigger now. I write bigger now after this.
No, you write 2 on the left, and then it's smaller than equals to X.
What to
and
write
then
from here now? Tell me what to write from here, from this point. You tell me what to write from this point. Can you hear me?
yes.
Okay, so tell me what to write now.
2 is smaller and or equal to X. And then smaller and equal to 5.
Like that. Confirm, is this what you want?
Yes.
Okay, so my question is, in this range, is X equals 2.5 within this range? It's a question that has nothing to do with the question you're doing. I'm just asking you in general. If you give me this range, is X equals 2.5 within this range, yes or no, and fast? Callista, can you hear me?
Yes.
This range, 2 less than or equal to X less than 5, is the value X equals 2.5 in this range?
Yeah.
Is the value X equals 4.8 in this range? That shouldn't take you more than 2 seconds to answer. I don't know why you're hesitating. Is it that you do not understand what that range is, or you don't know what I'm asking? So please tell me now so I can clarify, because that shouldn't take you more than 2 seconds, even in fact, less than a second to answer my yes or no. What exactly?
It's lagging a lot.
Is what?
It's like the video is lagging a lot over here. Wi-Fi's bad.
Oh, the audio. Okay, okay. So now this value is here, right? Okay, so now let's come to the graph. My 2.5 is somewhere here. There is no indication that it's part of the function. Can you see that?
Yeah.
So while you have an idea, I think you are missing something. The values you have there are points, is not a line. So your domain is simply each of the values of X. 2, 3, 4,
okay.
5. So what would be your range? So what would be your range?
1, 2, 3, and 4.
That's it. Okay, unless you have a line, you do not do this. I hope that is clear to everyone. Lillian, you're next. State your question. Tell us the answer.
I'm doing 6B.
6B. This? Oh, okay, you can't see.
Yeah.
This one.
So I wrote for the domain, X is a set of real numbers such that X is greater than or equal to -2.
All right.
And then the range is Y is a set of real numbers, but such that Y is less than or equal to 1, but less than 3.
Y is less than or equal?
I mean greater than or equal to 1.
Everybody now for the last time, stop writing separately when you can combine the inequalities. It doesn't make you look professional, in quotes. Can you write that Y properly now, the range properly?
So Y is, I mean 1. Do I start with 1 then? 1 is less than or equal to Y, which is less than 3.
Less than 3. So stop writing them separately. Write as combining inequalities. That's correct. Who is next? Let's see. After Lillian, we have Krista C. You're next. Your question and your response.
My question is 5B.
5B, let's see, 5B. This is 5B, yes?
And the domain is X equal to any real number except -2.
Any real number except -2, perfect. And the range?
Range Y equals to any real number except 0.
Y equals, oh my God, that's so wonderful. Well done. I like how it is so short and like, I'm short of words. Wonderful. Next, Clarissa, any luck? I noticed you sign on with another device. You could use
Yeah, can you hear me?
Oh, finally.
Okay.
Your question?
So my question is 2C.
2C. We go back up. 2C. 2C. Here you go. That's 2C.
Okay. The domain is X is a set of real numbers.
Good, because
Well,
it's indefinitely. Wonderful. Yes.
Yeah. And Y is in a range of real numbers while -5 is less than or equal to Y less than 5.
Less than or equal to 5.
Well, -5 is less than or equal to Y, which is less than 5.
My point is the last part should also be less than or equal to 5. Look at it.
Yes.
It crosses 5 as well, right?
Yeah.
Did you hear what you said? You said -5 less equal to Y less than 5. I'm saying they should be equal to here also.
Yeah. Also less than or equal to 5.
Exactly. That's correct. Well done. Next will be Nakita.
Mine is 6C.
6C, let's go to 6C. Okay, one of these. Is that 6C?
No.
No, that's 7, sorry.
Yeah, the green one.
Green one. Okay, here we go.
Okay. So the domain will be set of real number X. And then for range will be sets of real numbers Y such that Y equals to -1, 1, or 2.
That's it. Now, why is it all real number X? If you look at this point, it comes from -infinity up to less than 1, up to less than, what is this value? Okay, 0. This is less than 0, X less than 0, right? Here, it starts from greater than or equal to 0, but less than Then from here is 2 and above. So it's basically all real numbers. That's correct. And if you look at the range, there's only these 3 values of y. So that's correct. -1, 1, and 2. Well done. Who's next? Let's see. Leo.
I don't know if I got the correct answer.
I don't even know what's your question.
So, 6A.
6A.
The one left. Yeah, the first one.
So what's your domain?
X is a set of real number.
All real numbers.
And the range is y is greater or equal to -4. I don't know if that's correct.
How did you get that? I think they want you to do extra work on this. So let's check that together. Can anybody tell me how we can get, because I think Leo is looking for what this is, right?
Yeah. Yeah, but like it doesn't really make sense if that's -4. So I don't know if I got it correct.
So can anybody tell us how to get what y value this is? Anyone? Hello?
Maybe find the vertex, like using completing the square.
Completing the square, yes. So you find the minimum point. Okay, so let's write that. That is my x minus 1, x minus 5. Okay, so Leo, this is how you can go about that. Your equation, y equals x minus 1, x minus 5. And when you expand this, you get x squared minus 6x plus 5. Right, Leo? So y will be x squared minus 6x. You're going to add something to complete the square. You're going to subtract it to the same thing, and you have your plus 5 standing by. So what is that term to be added? Is half of this squared. So that's minus 3 squared, minus 3 squared. And because you're adding and subtracting it, then there's nothing changing. So basically, y equals, this is now your square, x minus 3 all squared, the rest will be evaluated, minus plus 9, because this is going to be plus 9, this minus remains minus, and plus 5. So y will be equal to x minus 3 all squared minus 4. Of course, we got minus 4. Is it safe to assume that you saw the answer somewhere, Mr. Leo, because you have your book with you? Mr. Leo?
No, because like when I look at the graph, one is -1 and one is -5. When I check the answer, the middle one should be -3.
Minus
so
4
like
in the graph. Anyway, so you are right. The minimum value is -4, and that's how we can figure that out from this calculation. Okay.
Yeah.
The minimum is -4. So y is definitely, so the range of f is set of y such that, that's another way instead of the vertical line, such that y is greater than or equal to -4. Okay. So who has not spoken in the class today? Has everyone answered the question? Let me see. Not everyone. Krista, not yet. I think Vena also not yet. Okay, Vena is done now. All right, let's have your question is the last one. The question is a bit technical, so I will understand if you're not able to figure everything out.
Yeah, but I'm not so sure about the range.
Yeah, let's just try, all right? Which one is it again? The last
7F.
The most complicated one. What happened? You don't sound like you.
Hmm?
You don't sound like you. What's going on?
I don't know.
No, okay. Sound like maybe I just wanted to be sure everything is okay. Anyways, let's see. Here we go. This, right?
Yep.
What is your domain?
The domain is set of real number x such that x is not -2 or 2.
That's correct. And your range?
Then the range is set of real number y such that 0 less than y less than or equal to -1.
Let's see. Say that again.
0 less than y less than or equal to -1.
0 less than y.
Less than or equal to -1.
Less than or equal to -1. But if you look at it, between -1 and 0 are not included, but that's exactly the point you are including. These are the points that are excluded. Can you see that?
0
This
less
part of
than
the graph, can you see my cursor?
Yeah, I wrote like, because it's a bit weird if I put it together. I think, can I just say it separately so it just makes a bit more sense?
Say it separately.
Yeah, so y is less than or equal to -1.
Y is less than or equal to -1.
And then y is greater than 0.
And y is greater than 0. So if you look at this, it cannot be combined. You can only combine inequalities that can be combined. Let me tell you what I mean by can be combined. Let's come to the board. Okay. So if you have y less than 1 and y greater than 2, on your number line, this is 1 and this is 2. Less than 1 comes this way, greater than 2 goes this way. These cannot be combined, so you have to write them separately.
Okay.
If on the other hand, you have y greater than 1 and y maybe less than 2. So if you look at the number line, this is 1 and this is 2. So greater than 1 goes forward, less than 2 comes backward, so they can be combined. So this is the inequality that you write in this form. So the lowest one is 1. So y greater than 1 means 1 less than y. Then this also y less than 2. So this is what I mean by combined inequality. But the combined inequality can only be done if they both satisfy the range. But in this case, not both of them satisfy the range. This satisfy a different direction, this one another direction. Am I making sense?
Yep.
So in the case of the graph, it is clear that the two the range you are discussing cannot be combined because they go to different direction. One is y greater than 0, one is y less than or equal to 1. So if you look at y greater than 0, y greater than 0, y less than or equal to -1. If you put them on the number line, y greater than 0 goes this way, y less than -1 comes this way, so they go opposite direction. So since they cannot be combined, you write them separately. So your range of f will be set of y in R such that y greater than 0, you can pick the -1 first because that's the one below the line, it doesn't matter. So I can say y less than -1, comma, y greater than 0. So you write them separately. Does that make sense? I hope everybody does that as well. Sorry, I have to log off this WhatsApp WeChat thing. The middle school group, just chatting and chatting. All right. Who is next? So well done. Let's see who has not spoken. Has everybody spoken? Krista K. Can Krista hear me, please?
Yes.
What is going on?
I can't hear you.
I can hear you too. Where's your work?
Question 5D.
Are you ready?
Yeah.
Okay. Now why are you sounding like something is wrong? Is everything all right?
Yeah.
Okay, you're just being lazy. 5 what again?
5D.
5D, D for my name. All right, here we go. This one?
Yeah.
All right, so what do you have? Domain?
The domain is set of real values of x such that -3 is smaller or equals to x and smaller or equals to 1.
Perfect. So domain is set of R such that -3 less than or equal to x less than or equal to 1. That's correct. Range?
The range is set of value of y and such that -4 is smaller or equal to y and smaller or equals to 0.
Smaller or equal to?
0.
0. That's correct. I think that will be the last one, isn't it? Everybody has spoken. Well done, well done. So we can do this graphically. You can, do a lot of things. So let's also, when we'll get to other functions, maybe like the trig functions later, we'll come back to domain. We'll get to rational function, we'll come back to domain. Now, all these are rational functions, okay? We'll talk about it later. So how do we get their graphs? Then the graph will help us out, especially with the domain. Now, let's consider some of these functions, quadratic functions. So everyone, maybe we pick, do we pick again? No need. So one of the ways to do this will be either to inspect or to do the graph. Another way to get the range is to consider the inverse of the function. We'll discuss that later, okay? I think we have done something on square roots. Okay, let's see. And this is modulus. Does everybody know what this means? Absolute value. Talk to me, class. Absolute value. Everybody knows what absolute value is, okay? Is there anyone who does not know what that absolute value sign means? I guess that's a no, nobody, all right? So we can also look at the absolute value functions. You can look at quadratic functions, okay? So if you sketch this, can somebody guess the domain of this? All these functions have something in common. The domain are the same. Do you agree? Hello? I need response, please. I need real-time response. And I keep seeing the same name, Ethan, Nakita, Lillian, I keep seeing the same name responding more often than the others. What is going on with the rest of you? So I ask again, this function, all this function in question 9 have something in common. Do we all know what that is in terms of their domain?
To the power of 2.
No, I know they are quadratic functions. They have the same domain. That's my point. I'm assuming they have the same domain. What is that?
All real numbers.
All real numbers. So any real number can be substituted here. Can I say the same for these ones? 10, 1 to 6. Can I say the same? No. Karen, I believe your mic works, so I need you to talk to the mic. Anyone responding should talk to the mic. Thank you. So we can't say the same here. So domain for this is sorted, but the problem is the range, right? So let's take this function. The range of this, can somebody try? The range will be what? Y equals x squared. The range will be what? I'm waiting.
Y is a set of real numbers such that it is greater or equal than 0.
Yeah, from 0 and above. Can someone else? Ethan said the first one, Lillian said the second one. I need someone to tell me the range of 9, 2.
a set of real number. Y is a set of real number that is less than or equal to 0.
Yes.
Wait, yeah.
Yes, because whatever you substitute, you always get a negative number. All right? Whatever you substitute, you get a negative because x squared will make it positive and there's a minus weighting to make it negative. And it can be easily seen in the graph. So if you put here x squared, so this is graph of x squared. So let's see what happens when you put negative. So this is graph of negative x squared. All right, so just like you said. Okay, how about this? Can someone try to tell us what the range will be? Someone else. Range of this.
A set of real numbers that is less than or equal to negative 18.
Negative 18, are you sure? Why do you say that? I'm asking you so I could correct whatever wrong impression you have, all right? So can you walk me through how you got the negative 18?
When x is equal to 0.
Good. So you assume that 0 is the minimum number you can substitute, but that's not always the case. Do you agree, Karen, that that bracket could be 0 itself when x is negative 3?
Oh.
Can you see that? Yes?
Yes.
So the minimum value that that square bracket could give you is 0. And at that point, you get 0 as the entire function. Okay? So x is not just less than negative 18. Your x actually will be less than or equal to, your y will be less than or equal to. That's my point. Let's plot the graph to see. You need to do a lot of practice. I'm talking to everybody to be able to see this. Can you see that? See the graph? Can you see the graph, Karen?
Yes.
You see that it begins from 0, not negative 18. Okay?
Yes.
All right, well done. So let's have, nice try. Can we have someone tell us the range of this? Waiting.
Y is smaller or equals to -1?
-1. Why do you say that? So -1 would be the minimum you can, the smaller or equal to -1. So this is going to be a maximum graph that turns at -1. Are you sure? Did you also substitute x is equal to 0?
Yeah.
Please don't plot the graph. I don't want anyone plotting the graph. You can't plot the graph in exam. So let's think first.
A set of real numbers y such that y is less than or equal to 1.
Less than or equal to 1. That's when the bracket is 0.
Yeah.
But can you get 1 out of the bracket?
Oh.
And 1 be generated from the bracket.
Yeah.
So if 1 can come out of the bracket, then y can also be 0.
No, I'm saying less than or equal to 1.
So that's my point. Oh, less than or equal to 1. Okay, I see what you mean. Less than or equal to 1. Let's see, okay? So, but then, if the minimum you can have here is 0, right?
Yeah.
Yeah. So when it is 0, you get 1.
And then anything more than that is less than 1.
0. Let's say when it is 4, you get what?
Negative 15.
No, when this bracket.
Wait, no. You get 4, so it should be negative 3.
Negative 3. So what is your range again?
It should be a set of real numbers y such that y is less than or equal to 1.
Less than or equal to 1. I think that would be it. So let's see.
Yeah.
Well, it's actually in terms of completing the square, isn't it? Right? So your 1, it makes sense to pick this 1. So let's plot the graph. 1 minus x minus 2 squared. Is there anyone who is confused? You see? All right. 1 is the turning point. Okay, y equals 1 is the maximum point. Is there anyone who is confused, please? Anyone? Yes, no, yes, no. Only 2 responded. 3, 4, 5. 5 out of 11. 6, 7, 8. 8 out of 11. I'm waiting for the last 3 to tell me if they are confused or not. Or has everyone responded? Maybe I miscounted the whatever. So anyway, that's that. The last one I want us to have a look at are these. Now these are restricted domain, right? These are restricted domains. So let me pick people at random. Callista, you're going to tell me the domain of this function. Krista C, you're going to tell me the domain of this function, number 4. Callista is number 6. Let's see. Leo, you're going to tell me the domain for number 2. Nakita, domain for number 5. Who's ready among those that I mentioned? Anyone ready? Mr. Chang, everything all right? You're breathing in and out?
Oh, I'm okay. No, I was just looking at the last question.
No, I'm just checking. Yes, who's ready, please? This is all we want to do today, to investigate how to find the mean and range using graphs, observing the function, algebraic method, among others. So that's all I want us to just focus on today. Since you have the paper, you can do your own self-practice. If I need to put a quiz online, like a short answer quiz, I will, and I will inform you. Otherwise, you're free to just do your self-practice on your own. Yes, who is ready, please? Ladies and gentlemen. I hope they got my questions. Can you signify if you got the question that I've assigned to you? Doing, okay. We're waiting so we can hold. Okay, Nakita is done. Let's hear from you.
The domain will be the set of real number x, and then such that x is less than or equal to 2.
What question is that?
1, 2, 3, 5.
Question 5. This one.
Yeah.
It says such that x is less than or equal to 2.
Yeah.
So anything more than 2 cannot be x. That's right. So to get the and Nakita hear me and everybody.
Yeah.
So to get the value that is excluded from the domain, what is the best thing to do? Anybody? Value that is excluded from the domain, what is the best thing to do?
We can't hear you.
You can't hear me.
It's a bit like
Okay.
not loud enough.
Okay, can everybody mute their mic? Then you can talk after because I can hear some background noise. So my question is, to get the value that is excluded from the domain, what is the best thing to do? So turn on your mic and answer the question. Anyone?
Is it take what's inside the square root and then equate it to 0?
Not equal to 0. Close.
Like not 0?
It could be 0. You just take what is inside the square root and put greater than 0. So in this case, it will be 2 minus x greater than or equal to 0. Now actually, yes, greater than or equal to 0. That's not the excluded part, that's the included one. So your square root, the values in the square root must be greater than or equal to 0, basically, right? And you solve the inequality. Does that make sense? Class? All right, so to solve that inequality, you're going to be getting 2 greater than or equal to 0 or greater than or equal to x, and x will be less than or equal to 2. So I'll put that on the board now. So let's see, this is what I mean. Okay, can everybody see the board? All right, so I'm going to be going back to the question. So for this, Nakita's question will be this, right? Number 5. So if you come back, y equals 1 minus 3 root 2 minus x. Now, not every value can be substituted in this function. So you get the possible values that can be substituted are those values that will make this define in a real set of real numbers, all right? The values that will make this define means the value that will produce the values that will make these terms under the square root more than 0. So you solve a simple inequality if you must get 2 minus x to be greater than or equal to 0, because it could be 0 or it could be more than 0. If you must get this to be more than 0, it means negative x must be more than or equal to negative 2, and your x will be less than or equal to 2. Okay, or you could do 2 minus x more than or equal to 0 means 2 must be greater than or equal to x. It means x must be less than or equal to 2. So when you are specifying your domain, the domain of the function will be all real number x such that x has to be less than or equal to 2. Okay? Questions? All right, so that's the easiest way to go about it. Who is the next person? Who is the next, please? I assign questions to people. Can I get a response, please? Is Colista ready with her answer? So what question is yours and what is your answer?
Question 6.
Question 6. Okay, so let's go back to that.
Mm-hmm.
All right, this one?
Mm-hmm.
All right, so what do we have?
X is a set of real numbers such as X is bigger or equals to -1/2.
Perfect. Who is the next person? I think I assigned to about 3 or 4 people. Who are those people that are assigned to? Can you signify by indicating I assign question to you? We're wasting our time. Did I assign to Leo? Yes, Crystal, Leo. Who else did I assign to? Yes. So what's going on?
Can I answer the question 4?
Who's that?
Crystal C.
Yes, please.
I think X is less than or equal to 1/2.
Yes. Excluding X must be, so everything less than or equal to 1/2. Yes, that's correct. Who is the next? So basically it's the same principle. 2 minus 4x must be greater than or equal to 0. That's what you did, right?
Yes.
All right. So x must be less than or equal to 1/2. Correct. So all real numbers such that x is less than or equal to 1/2. Yes. Who is next? Leo?
Yeah. Number 2.
Number 2.
I. So the domain is set of real number and x is greater or x is greater or equal to 2/3.
Say it from the beginning.
So x is set of real number.
X is not set of real numbers. X is just a number.
Oh, okay. X is a number, and the domain is greater. No, domain is set of real number. X is greater or equal to 2/3.
Such that real number x, Leo, domain is set
the real number
x, such that yes.
X is greater or equal to 2/3.
That's correct. Such that x is greater than or equal to 2/3. So it's not all the time you have less than or equal to. Okay. So you can use graph. You can then I need you to go and think about how to get the range of some of these functions. I will advise that you try them on paper first, and then you can plot the graph to check. Okay. Let's plot graph of inequality, absolute value, so you know what to expect. For absolute value functions, the graph will look like this. That's what the graph will look like, absolute value functions. Absolute value function means it's only positive. So even when you substitute negative, positive comes out. That is why even for negative x values, you only have positive y. And for positive y value, you still have positive y. So absolute value function is always in form of a V shape. Okay? At least for the linear part. And if you put a negative, then it flips. So you can see now, it flips. Okay? So use this idea. If I put maybe like -1 inside, you see there'll be a difference. Okay, so you can see the transformation. Okay, it moves along x-axis by 1. If this was +1, let's see the difference. Can you see it moves towards the negative by 1? So basically, the minimum value that an absolute value can give you is 0. Okay, that's the minimum. Do we all agree? Talk to me, please. The minimum you can get from an absolute value function is a 0. Yes. So for this to be minimum, x has to be -1. That's why you're having this. Does that make sense? And on the other hand, if this was minus, for this to be minimum, which is when everything is equal to 0, x has to be 1. So you can use that to have an idea what to get. If you put a multiple, it means the y value is multiplied. So if this is 3, okay, you can see it stretches. So let's see. So instead of normal x, it's being multiplied by 3. For example, when x is 0, okay, y is 0. When x is 1, y will be 3. You can see that. When x is 1, y is 3. Okay? If this was -1, when x is 0, I get y to be 3. That's why it's crossing it at this point. Okay? So you can always use this idea to maybe think about this set of questions. Use graph to check your findings. You can sketch first, okay? You can sketch the graph and find the domain. Please don't put it online first. Try to sketch the graph first. And for the ones that are quadratic form, okay, the best thing to do is to see if there is an intersection with the x-axis or not. Where does it cross the x-axis? So which means you have to be able to, the minimum value is when everything here is 0, as we said. So you have to solve this equation, okay? You have to solve this equation to see where it crosses, okay? So for example, if I want to do, if I want to see the domain and range of functions like y equals absolute value of x squared minus 5x plus 6, for example. Maybe that is too close. About, say, minus x minus 12, which will give me 3 and 4. All right. So the minimum is when this is 0. So when this is 0, x squared minus x minus 12 is equal to 0. I get x plus 3, x minus 4. So x will be equal to -3 and x is equal to 4. So which means at the minimum, it's going to touch at -3 and 4 at the minimum. Okay? And at that minimum, what will be my y values? At x is -3, I get y to be 0. So it crosses, yes, good. So it's not going to come to the negative. So it's going to turn, go like that, and turn again, something like that. Does this make sense? Talk to me, guys. All right. So let's see on the plane. X squared minus x minus 12. Can we see that? You see? So it goes, where does it turn anyway? At 12. No more than 12 actually. Okay. So it's crossing. This is still the intercept. All right. So it has the y-intercept here. That is when x is 0. Yeah, that makes sense. And this is the turning point. Okay. So this is what it will look like. So from here, you could see that my domain is all x.
Mr. Daniel, we cannot see the screen.
Oh, what do you see now?
The whiteboard.
Uh-oh, sorry. How about now? Yes, okay, good. So you could see I put this in, and this is what I get. You see, it touches at -3 and 4, which is when at the minimum. So all you have to do is solve if there was no calculator to do the graph plotting, you solve this because that's the minimum. You want to see what happens at the minimum because it's an absolute value function. And it is minimum when this whole thing is equal to 0. That is the least an absolute value function can have. So, and you see that after solving, this is what we get. So because it doesn't come to the below the y-axis, whenever it turns here, it goes back up again. So we don't need to know where it gets to. But you could see that the intercept is still 12, which is when x is equal to 0. Okay, you still get your y-intercept to be 12. Anyway, so that's that. So if you look at it, all x can be substituted, and your y, which is your range, is from 0 and above. So it's going to be y such that y greater than or equal to 0. All real y such that y greater than or equal to 0. Okay? And if this happens to be maybe +1, let's see what difference it made. Can you see it jumps up? Okay? So in that case, it will be all y such that y greater than or equal to 1. Am I making sense, please? All right. So if I have here a 3, it really doesn't make any difference because still the minimum here could be 0. So the multiple doesn't make any difference much, okay? The difference is in how tiny this becomes. Because if this is not there, if this was maybe 0.01, can you see? Can you see? So if this was, if this was 0.1, can you see? Can you see that? Compared to when this is just 1. Okay, so what really makes it jump up or down is what you have after the function. So if this was -1, then you are assured that while this function has a minimum value of 0, -1 makes it possible for it to be below the y-axis, as you can see now. So you have to be considerate of all this when trying to attempt this question without graph. So after you have attempted the question, then feel free to plot it on the maybe Decimals application or even your calculator. I think your calculator also have the graphing, and play around with all this domain and range on your own. Okay, that's how to learn. Any questions before we go? Hello, any questions? All right, so we'll stop here. So next time we'll be looking at, I think, the idea of composite rational function. I'll see which one will come first in our book and also to aid our understanding. So this is the main one that's usually problematic to people. We'll be looking at types of function, onto function, that's one we talk about one-to-one function, okay, we'll talk about bijective function, and so on and so forth, or bijective mapping. We'll talk about all those types. Constant, what is an identity function? We'll talk about that briefly, and we'll look at the applications, okay? Especially under inverse, there is a need for us to actually understand the identity function, because of when we do inverse and composite, we can see the connection between them, all right? If you have your book, please look at the chapter. Some of these are from the book. Some of them are from other materials that I have, and some of them I just pick randomly from elsewhere, okay? So please practice more on domain and range. Again, you can look at it algebraic-wise, can look at it graphical-wise. Graphical-wise makes it easier, but not all the cases you have access to the graph of the functions. So you need to either sketch the graph yourself or just try to picture it and say, okay, what value can I substitute? What are the possible values I can never get? Okay. We're going to revisit domain and range under rational functions also. Then we'll be talking about undefined fraction that you already know. Remember, when the fraction is undefined, the denominator is equal to 0. We'll be looking at that much later. In rational function, also we'll be looking at the asymptote to the curve, which is the dotted line that it approaches but it never touches, okay? How to get those these lines, we will discuss that under rational functions. All right, if there are no questions, please make use of the rest of the paper to practice on your own, and have a wonderful evening. I will see you on Friday. It's Friday, that's tomorrow. I'll see you tomorrow. Okay, bye everyone.